Hello, fellow Earthlings. Welcome to a journey into one of the most enigmatic and remote regions of our planet. Today we journey to the Arctic, a land of ice and mystery. This vast, frozen expanse holds secrets that have puzzled scientists and explorers for centuries. We will explore a phenomenon that is as fascinating as it is concerning: the appearance of giant sinkholes. These massive voids in the Earth are not just geological curiosities. They are windows into the dynamic processes shaping our planet. These sinkholes are not just holes in the ground, they are complex structures formed by the interplay of ice, water and soil, revealing the intricate balance of natural forces at work. They are signs of a changing world, a world grappling with the impacts of climate change. As temperatures rise, the ice that has held the ground together for millennia is melting, leading to the formation of these dramatic features. Our journey takes us to the Yamal Peninsula in Siberia, a vast expanse of frozen ground known as Permafrost. This region, with its harsh climate and remote location, is a critical area for studying the effects of global warming. This frozen land, once thought to be eternally stable, is now revealing a hidden, secret massive craters that seem to appear out of nowhere. These craters are formed by the sudden release of methane gas trapped in the permafrost, a process that is both spectacular and alarming. These craters are not the work of aliens or ancient civilizations. They are natural phenomena, but their sudden appearance and the forces behind them are a stark reminder of the delicate balance of our planet's ecosystems. They are a stark reminder of the power of nature and the consequences of a warming planet. As we continue to study these features, we gain valuable insights into the processes driving climate change and the urgent need to address its impacts. Join us as we delve deeper into this frozen mystery and uncover the secrets of the Arctic's changing landscape. In the summer of 2014, reindeer herders in the Yamal Peninsula stumbled upon a sight that left them baffled. A gaping hole in the ground, stretching over 200 feet wide and plunging deep into the earth. This was an unprecedented phenomenon in the region, something they had never encountered before. This was no ordinary sinkhole. The sheer size and sudden appearance of the hole suggested that a powerful force had been at work, one that was both mysterious and potentially dangerous. Its size and the force with which it appeared suggested something extraordinary had taken place. The local community was both fascinated and fearful, as they had no idea what could have caused such a dramatic event. News of the discovery spread quickly, capturing the attention of scientists worldwide. Media outlets from around the globe reported on the mysterious sinkhole, sparking a wave of curiosity and concern. Intrigued and puzzled, they embarked on expeditions to the remote region, eager to unravel the mystery of the Siberian sinkhole. Teams of researchers from various disciplines, including geology, climate science and environmental studies, converged on the Yamal Peninsula. What they found there would challenge their understanding of the Arctic and its fragile ecosystem. The sinkhole provided a unique opportunity to study the effects of climate change in one of the most sensitive regions on Earth. As they delved deeper into their research, they began to uncover clues that pointed to a complex interplay of natural forces, including thawing permafrost and methane gas eruptions that could have triggered the formation of the sinkhole. The first order of business was to understand what caused this massive hole to appear. Initial observations revealed a crater with steep sides resembling an inverted cone. The surrounding vegetation was scorched and scattered, as if a powerful force had erupted from below. The sheer size and unusual shape of the crater ruled out typical sinkhole formation processes. These usually involve the gradual dissolution of underground rock layers by acidic water. Something far more dramatic had occurred in the Yamal Peninsula, leaving scientists searching for answers. The possibility of an asteroid impact was considered, given the crater's resemblance to impact sites found on other celestial bodies. However, this theory was quickly dismissed. There was no evidence of extraterrestrial material, and the nature of the surrounding debris pointed to a different culprit. The evidence suggested an explosion, but not one caused by conventional explosives. The force of the blast, the scorched vegetation, and the presence of certain gases all hinted at a more natural yet equally powerful source: methane gas. Section 5. The Methane Connection. Methane, a potent greenhouse gas, is known to exist in large quantities beneath permafrost. As permafrost thaws, it can release this trapped methane into the atmosphere, creating a potential environmental hazard. Could this be the key to the Siberian sinkhole mystery? Scientists discovered high concentrations of methane in and around the crater, confirming their suspicions. The thawing permafrost was releasing methane, which had built up pressure beneath the surface. This pressure eventually became too great, resulting in a powerful explosion that ripped through the frozen ground, creating the massive sinkhole. Section 6. Thawing permafrost, a recipe for disaster. The discovery of the methane-driven sinkhole sent shockwaves through the scientific community. It highlighted a previously underestimated consequence of climate change, the thawing of permafrost. Permafrost, ground that remains frozen for at least 2 consecutive years, covers vast areas of the Arctic. This frozen ground acts as a giant freezer, storing vast amounts of organic matter, including dead plants and animals. As permafrost thaws, this organic matter decomposes, releasing methane and carbon dioxide into the atmosphere. These greenhouse gases contribute to further warming, creating a dangerous feedback loop. Section 7. Climate change, the unseen hand. The link between the Siberian sinkholes and climate change is undeniable. The Arctic is warming at twice the rate of the rest of the planet, causing permafrost to thaw at an alarming rate. This thawing releases greenhouse gases, further accelerating climate change and perpetuating the cycle. The consequences of this feedback loop are far-reaching. Rising global temperatures lead to more extreme weather events, melting glaciers, and rising sea levels, threatening ecosystems and human societies worldwide. The Siberian sinkholes serve as a stark reminder of the interconnectedness of our planet and the urgent need for climate action. Section 8. A world at risk. The environmental impacts of thawing permafrost extend beyond the Arctic. The release of methane, a greenhouse gas far more potent than carbon dioxide in the short term, has the potential to accelerate global warming significantly. This could have devastating consequences for our planet, leading to more frequent and intense heat waves, droughts, and floods. Moreover, the thawing permafrost poses a direct threat to Arctic communities and infrastructure. Buildings, roads, and pipelines built on permafrost are at risk of collapsing as the ground beneath them thaws and becomes unstable. This poses significant risks to human safety and economic development in the region. Section 9. Science to the rescue. In the face of these challenges, scientific research is more critical than ever. The Arctic, a region known for its extreme conditions, is undergoing rapid changes due to climate change. These changes pose significant threats not only to the local environment but also to the global climate system. Scientists are working tirelessly to monitor permafrost thaw, understand its complexities, and develop strategies to mitigate its impacts. This involves a range of activities, from setting up sophisticated monitoring equipment to conducting detailed field studies. This includes studying the release of greenhouse gases which are trapped in the permafrost and released as it thaws. These gases, such as methane and carbon dioxide, contribute significantly to global warming. Developing early warning systems for sinkhole formation is another critical area of research. These systems can help predict and prevent potential disasters caused by sudden ground collapses. Scientists are also exploring ways to slow down or even reverse permafrost thaw. This could involve innovative techniques such as artificial cooling or the use of reflective materials to reduce heat absorption. International collaboration is crucial in this endeavor. Scientists from around the world are pooling their knowledge and resources to tackle this pressing issue. Sharing data, expertise, and resources will enable us to address this global challenge more effectively. Collaborative efforts ensure that the best minds are working together, leveraging diverse perspectives and skills. By working together, we can strive to understand and mitigate the impacts of permafrost thaw and protect our planet for future generations. The combined efforts of the scientific community offer hope and a path forward in the face of this daunting challenge. Section 10. The future of the Arctic. The future of the Arctic hangs in the balance. The fate of this fragile ecosystem, and indeed the planet as a whole, depends on our actions today. We must act decisively to reduce greenhouse gas emissions and limit global warming. The Paris Agreement, an international treaty aimed at combating climate change, provides a framework for global cooperation. By transitioning to clean energy sources, Investing in sustainable infrastructure and adopting responsible consumption patterns, we can create a more sustainable future for all. Section 11, our call to action. The mysterious sinkholes of the Arctic are a wake-up call, a reminder that climate change is not a distant threat but a present reality. We must heed this warning and take responsibility for our planet's well-being. The time for complacency is over. The time for action is now. Let us work together to protect our planet, preserve its biodiversity, and ensure a healthy and sustainable future for generations to come. The fate of the Arctic, and indeed our own, depends on it.